Hello everybody, I am Avik Biswas and today we will be discussing about circular linked lists. So what is a circular linked list? It is a linked list where all its nodes are connected to form a circle. That is, the last node instead of pointing to null points back to the first node. Now what is the need of such a data structure? So there are multiple advantages of a circular linked list. For example, in a singly linked linear list, if you are given any node at the middle, if you have the reference of any node at the middle, you will not be able to traverse the whole list because, for example, if you have the node with value 3 as a starting point, you will not be able to go back to the preceding nodes. You can only move forward. So you will not be able to traverse the whole list. But in a circular linked list, you will always be able to go back to the starting point from the last node. So this is the pseudocode of traversing a circular singly linked list. So let's say we have the node 3 as a starting point. So this is S. And we then assign start.next to a current pointer, and in each iteration we just move the current pointer by one step. So in the first iteration, current pointer moves to node 4, and then we move it to node with the value 1, then 2, and this continues as long as the current pointer doesn't point back to the original node, that is the starting point. So in this way we could traverse the whole list despite having the reference to a node in the middle. Now let's see another advantage of a circular linked list. It is helpful for the implementation of queues. So if we have a singly linked linear list and we implement a queue using that, then we have to maintain two different pointers, the first and the last, to represent the queue. So this is the first and this is the last. So in case we are inserting a node in the queue implemented using a singly linked linear list, then let's say we are inserting a node with value 5. So we point the last node of the queue to the new node and move the last pointer to the new node. Similarly, for removing a node from the queue, we have to move the first pointer to the next of the first node and delete the first node. So we need two pointers over here, but in a circular singly linked list, we can do the same thing using just a single pointer, which is the last pointer of the list. So what we do over here is that, so this is possible because the first node is always accessible from the last node. Now you may ask that we could have represented the circular queue using the first node as well. Well, in that case, if we represent the queue using the first node, in the enqueue operation, when we want to add an element to that queue, then we have to traverse the whole list to the last node, so that we can point the last node to that new node. So that will be actually a ON operation, where n is the number of nodes in that queue. But if we use the last node to represent the queue, then it will, both the insertion and deletion operations will take O1 time, that is fixed time. That is because the first node is always the next of the last node. So that's why using a singly linked circular list, we can implement a queue and represent it just by a single pointer, that is the last node of that queue. Now let's go through the enqueue and dequeue operations on a circular queue. So over here the queue is represented by the last node, so last, and we assign that to the last pointer in this pseudocode. So first we check that whether the queue is empty. If so, so let's say first of all the new node, for example, if we want to add a node with a value 5 to the existing queue, then the new node is actually, while creating the new node, we point the new node back to itself, because we are inserting in a circular queue. So If the list is empty, if the queue is empty, then we just make the last pointer of the queue point to the new node. So this will be the last, and this is the entire queue. But this is not the case over here. So over here, the first equal to, and this is the last node, and first equal to last dot next, which is a node with value 1, and last dot next equal to new node. So we break this link and point back and point into the new node, and then new node dot next equal to first, and point the new node back to the first node. And at the last, the most important thing, we need to change the last pointer of the queue to this new node. So this is our new queue. Now let's go through the dequeue operation. In the dequeue operation, again we do a null check. If the queue is empty, then we just return from there. We do not do anything else. If the queue has only a single node like this, then we just make this is the last pointer pointing to that single node. We just make last equal to null and come back from there. In this case, we get the first pointer of the queue is using last dot next. So this is the first pointer of the queue, and we make the last dot next equal to first dot next. So we point the last node of the list to the first dot next, which is a node with value 2 over here. And depending upon the programming language that you are using, you can explicitly free the memory allocated for this node, or it can be automatically garbage collected. So, and finally, this will be your new queue. Well, so that was it. So today we learned what is a circular singly linked list, what are its advantages over a linear singly linked list, and how a circular linked list can be used in the implementation of a queue. Thank you.